So in this lecture, let's discuss one example to solve a problem in kinematics. But before that, let's talk some basic things. First of all, is negative of a vector, and we already have talked about vectors, but we forgot to talk about negative of a vector. So let's talk it right now. If you have a vector something like this, AB, then the negative of a vector is just a vector in the opposite direction, like that. So this is AB and this is minus AB. And if AB has a Cartesian representation AX comma AY, which means this is AX and this is AY, then minus AB has a Cartesian representation minus AX comma minus AY. You can clearly see this is minus AY down the negative y-axis, and this is minus AX, negative x-axis. So that's about negative of a vector. The other thing I want to talk about is gravity. Well, we all know that if we drop something, then it falls towards the Earth's center, and the velocity of that thing increases as it goes down. So we already know that whenever there's a change in velocity of any object, then there is an associated acceleration, and which is what gravity does. So gravity is actually an acceleration. It accelerates the object, and the value is close to 9.8 meters per second square. So these are and there's one more thing, is the equations we talked about in the previous lecture, which were xf equals xi plus v tf minus ti plus half a tf minus ti squared, vf squared equals vi squared plus 2a xf minus xi, and the third formula was vf equals vi plus a tf minus ti. Let's make it look better. Ti. Okay, let's solve a problem. Now remember, this is the motion in one dimension, so we are talking about displacement in one dimension. So what we have, let's take an example. We have a tall building, and let's say this is 30 meter tall, and I'm standing on top of it, and I'm tied with the chain so that I don't fall down, and I throw a ball up with a velocity of 10 meters per second, and I'm being asked, when it drops down and hits the ground, what is the final velocity and how long was it in air, which means what is TF minus TI. Alright, and for the sake of simplicity, we can assume TI to be 0, and also for the sake of simplicity, we can assume XI to be 0. Then if we want to assume xi to be 0, we want our coordinate system to be here. Well, this is a problem of displacement, so we need to specify an axis system. This is always make sure whenever you're solving a problem on vectors, even if one dimensional, always define an axis system. So let's call this axis going up as the x-axis. Well, we have defined x like this and y like that, but it doesn't really stop me from defining x up and y like this. But anyway, y is not playing any role in here. It's just one-dimensional motion, so it's just the x-axis. Okay, with this definition, what is xf? You see, x is 0 here. This is the origin. This is where x is 0. What is xf in this problem? And if you look closely, it's minus 30 meters, right? Moreover, what is g? Well, you see, g is pointing downward, and positive x-axis is in the up direction, same as here. So g will also be a negative. It will be minus 9.8 meters per second square, right? So I chose this example just to help you understand the science. That when this vector is negative, a vector is negative when it's pointed towards the negative x or y axis, or both of them. So here the vector g as well as xf. What is xf? Well, if you look closely, this whole vector is xf, and it's pointed right here. This is the vector, and xf is minus 30 meters. Now let's see if we can find vf. Now, do you think you can use any of these formulas to find the value of vf? Well, I think we can use this particular formula, the second one, to find the value of vf. Let's try that. So vf squared equals vi squared, which is 10 squared, plus 2 into 9.8 multiplied by xf is, well, minus, I forgot, minus 30, and that gives us 100 plus, let's assume this is close to 10, so let's assume this to be 10. That way it will become easier, so it becomes 600, and the sum is 700. So vf is going to be square root of 700 meters per second. Well, is it positive or negative? Should we choose the positive square root or the negative square root? Well, you see, vf is pointed downward, right? vf, when the ball is going to hit the ground, the velocity is pointing downward. So if the velocity is pointing downward and the positive x-axis is pointing upward, we are going to choose the negative sign, right? Now the time of flight. How to find the time of flight? For which we can use the last formula, the third one. We already have vf, so we can say minus 700 equals vi, which is 10 minus 9.8. let's take it 10 so that we avoid, and tf minus ti, we already have assumed ti to be 0, so it's tf, and that gives us 10 tf equals 10 plus square root of 700. You can use your calculators to find this value, and tf turns out to be 10 plus square root of 700 divided by 10, which if you do a small calculation will turn out to be this. So this is tf. Ti was already, we have assumed to be 0, and this is the time of flight. So the lesson learned in this particular lecture is that whenever you solve a one-dimensional kind, even two-dimensional, which we'll learn later, kinematic problem, always define an axis system and then follow the proper sign convention. In this case we chose x axis to be in the up direction, so the vector, so we have vectors to deal with here. So g is a vector which is pointing downward, so g is going to be minus 9.8 meters per second square. Similarly, xf is the displacement vector which is pointing downward from origin O, so this is going to be minus 30 meters. And then once we have figured out the sign convention, it's just a matter of using these equations to solve for whatever the problem is asking, and no problem will be difficult to solve. I'll suggest solve some problems, and I'm sure you'll be very comfortable with that. And in the next class we will talk about kinematics in 2 dimensions.